Welcome to aminacademy.com. In mathematical formulae and their explanation, let us discuss about 3D geometry equation of plane. General equation of the plane you can write as ax plus by plus cz plus d equal to 0, where a, b, c, d are constants. Next one, general equation of a plane passing through the points x1, y1, z1, x2, y2, z2, x3, y3, z3. There are 3 points are given. We can write general equation is in determinant form x minus x1, y minus y1, z minus z1, and x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, x3 minus x1, y3 minus y1, z3 minus determinant, which is equal to 0. You can write this form also, that is x minus x1 by a, y minus y1 by b, z minus z1 by c. Here, these are direction cosines of the line forming. That is, or we can write this in another form. Look at here. Here, this minor, that is y2 minus y1, z2 minus z1, y3 minus y1, z3 minus z1 into x minus x1 plus z2 minus z1, x2 minus x1 over z1 minus z3 minus z1, x3 minus x1 into y minus y1. Then plus x3 minus x1 and y2 minus y1, x3 minus x1, y3 minus y1 into this vector, that is z minus z1 equals 0. That is, this is in expanded form. This is a determinant. Then that it's the expanded form is here. Next one, equation of a plane in intercept form. Here, the plane passes through the axis, x-axis, y-axis, and z-axis. So the intercept in x-axis is a 0 0, y-axis is 0 b 0, and z-axis is 0 0 c. Then its equation is x over a plus y over b plus z over c equal to 0, equal to 1. It's not 0, it's equal to 1. Next one, equation of a line through the point x0, y0, z0 and perpendicular to the plane ax plus by plus cz plus d equals 0. Here, the point equation of the line passing through the point. That you have to find the equation of the line which is passing through the x0, y0, z0 and normal to the plan is equal, normal perpendicular to the plan ax plus by plus cz plus b equals 0 is x over x minus x0 over a plus y minus y0 over b z minus z0 by c. These are equal things, not less. Then or we can say x0 is x is x0, x is x equal to x0 plus at and y equal y0 plus bt and z0 plus ct, where note that the direction numbers are a line perpendicular to ax plus by plus cz plus d equals 0 or that is direction numbers. Direction numbers means direction ratios. Direction numbers are A, B, C. That is which is perpendicular to the plane ax plus by plus cz plus d equal to 0. Then next one, distance from the point x0, y0, z0 to the plane ax plus by plus cz plus d equals 0. Here the plan is given. Any point in the space P is given as x0, P is the point x0, y0, z0. Then we can find that equation of that plan is distance, that is distance between the point to the plan, which means the line joining perpendicular to the plan to that point is distance d equal ax0 plus by0 plus c z0 plus d over the square root of the addition, the square of, that is plus or minus a square plus b square plus c square. Is a perpendicular distance. Next is normal form for equation of plane. Here normal form, look at here, that means perpendicular distance from the origin to that point is given, that is P. Then you have to find equation of the plane, which is normal distance, some distance from the origin. Perpendicular distance from the origin is x cos alpha, y cos beta plus z cos gamma equal P, where here P is a perpendicular distance and alpha beta gamma angles between OP and XYZ axis. Here this is a P is the perpendicular distance and angle alpha beta gamma are angle between that perpendicular line from the origin to that axis X, Y, Z. Next, transformation of a coordinate involving pure translation. That means in XYZ plan, XYZ coordinate system, that here one object is translated to another position. That means it's one without rotation, it's a pure movements, pure translation. That is, we can get it here, the point x equal x0 x dash plus x0, x dash plus x0, y equal y dash plus y0, z equal z dash plus z0. Then this can be written as, or look at here, x dash equal x minus x0, y dash equal to y minus y0, and z dash equal to z minus z0. Here that means this where x, y, z are old coordinates and the coordinates relative to xy system, x dash, y dash, z dash are new coordinates. Therefore, new coordinate x dash, y dash, z dash are expressed as x minus x dash, that is old coordinates is subtracted. X, y, z is old coordinate, and from the old coordinates we have to subtract this translated and we have to subtract x0, y0, z0 respectively. Next, transformation of a coordinate involving pure rotation. That is, look at here, in xyz system, here the coordinate system is rotated through clockwise or anti-clockwise regarding the problem. Then we can find the coordinate system is x equal L1 x dash plus L2 y dash L3 z dash. Then y equal M1 x dash M2 y dash and 3 z dash M3 z dash. Then z equal n dash n1 x dash n2 y dash n3 z dash. Or this system can be written from that, or x dash is L1 x M1 y plus N1 z, or y dash M L2 x M2y and 2z. Z dash equal L3x M3y and 3z, where the origin of xyz and x dash, y dash, z dash system are the same, and L1 M1 N1 L2 M2 N2 and L3 M3 N3 are the direction cosines of the points x dash, y dash, z dash, axis relative to the xyz axis. Here these are the combination is given. Next, transformation of coordinate involving translation and rotation. That means first the point, one point is translated, then it is rotated. So we have two translation together. For this, the coordinate system we have to write this x equal L1 x dash L2 y dash plus L3 z dash plus x0 is x0 is the initial point. Then same for y, M2 M1 x dash plus M2 y dash and 3 z dash plus y0. Then z equal n1 x dash n2 y dash n3 z dash plus z0. Here this, after getting translation and rotation, we can write this as x dash equal L1 x minus x0 plus M1 y minus y0 plus N1 z minus z0. Same for y dash equal L2 x minus x0 M2 y minus y0 and N2 z minus z0, and z dash equal L3 x minus x0 M3 y minus y0 and M3 z minus z0. Next one, we'll discuss about what is cylindrical coordinates. First, cylindrical coordinate. A point P in a space can be located by cylindrical coordinates r theta z as well as rectangular coordinates xyz. The transformation between these coordinates is here x equal r cos theta. X equal to r cos theta, so polar coordinates, and y equal r sin theta, and z equal to z. So it is transformed as a cylindrical coordinates. Then r equal square root of x square plus y square, and theta equal tan inverse y over x, and z equal to z. That means z is the axis, center axis of the cylinder. That means this is transformed, these polar coordinates in Cartesian system, polar coordinates first, then from that it's a cylindrical coordinates converted. Next one, spherical coordinates. Spherical coordinates, that means it is in the sphere, it's move. That means look at here, then spherical coordinates, this here x equal r sin theta cos phi, y equal r sin theta sin phi, z equal r cos theta. Then this is transformed to spherical coordinates, where r equal square root of x squared plus y squared plus z squared, and phi, angle phi equal tan inverse y over z, y over x, and theta equal cos inverse z over square root of x squared plus y squared plus z squared. So far we discussed about coordinate system, that is equation of the plane, in different form as well as different coordinate system. We have done. Please subscribe our YouTube channel.